Okay, guys, let's get back together, please. What I'm about to talk about here, you guys will be doing in the lab real soon. Head up, please. All right, pay attention with me, please. You will be doing on Tuesday, actually. Is it this Tuesday? Yes. You're gonna do staining 1. The following Tuesday, you'll be doing staining 2. So this becomes my discussion to prepare you for those 2 labs. This this type of setup here we used to do, but we don't do it anymore. But I'll explain it to you what that is. This is basically used when we're looking at living organisms. So if you're looking at, for example, a sample of pond water, you know there is life in that water, and you want to see it, you're going to do one of 2 techniques, either the hanging drop method or the wet mount method. The hanging drop method, just like it says here, it's actually you put the drop of water or sample on the cover slip. And then you put a little bit of petroleum jelly on the edges. And it's a little technique-wise, it's a little tricky, but you have to flip the slide so that the drop or sample is hanging inside this concave depression in the glass slide. So there's your sample right there. And you're sealing the edges of it with this jelly. Why? Because when the light shines through, the light will also put heat in the sample, and if it's not sealed, that water, that little drop of water, will evaporate real fast. Before you put your eye to it's gone, and you're not going to see anything. So you're sealing it so it does not evaporate, at least gives you some time to look at it. So what is the advantage of this? Is to see living organisms in their natural environment right under the microscope. A little technical to do, so what we used to do in the lab is much easier than this. We're not going to do it, but we used to do it. Is you simply take a drop of water, put it on the actual slide, and put a cover slip right over it. So it does spread it out, but it serves the same function. All right. On Tuesday, however, you're going to be doing something different. You're not going to do these living organisms. You're going to actually do this. The negative stain and the positive stain. Each student on Tuesday will do 1 positive stain and 1 negative stain. This is the negative stain procedure. And this is the positive. Let me explain it to you. You're gonna put a drop of dye. It's gonna, you'll see, I'll talk about it on Tuesday again. It's called nigrosin on one edge of the slide, on this side of the slide, not in the middle. Then you're gonna add your bacteria, and I will actually demo it to you. And then you're gonna take another slide at a 45-degree angle and on purpose smear that sample in one continuous motion. You're gonna smear the sample and it's gonna look like this after you're done. And you're gonna simply leave it alone to air dry. When you put the slide under the microscope, you're gonna see something that looks like this. Obviously, whoever did this used the bacillus, the rod shape. And if you notice, it's the background that is stained, not the actual bacterial cell. The cell itself is not stained.
It's kind of like a contrast.
Exactly. It's the background that's stained. Now, there's a reason behind that. And that's very important to know. The cell itself is negatively charged. All cells are negatively charged on the inside, including your cells. You have DNA, yeah, it's negatively charged. There are a lot of proteins in there that are negatively charged. So when we look at cells interior, and we ask, overall, what's the charge? Negative. Well, the nigrosin that you're using is also negatively charged. So does negative like negative? No, they don't. They hate each other, right? They repel. That's why you do not stain the sample itself. You're using a negative stain. The negative stain cannot stain the cell because the cell itself is also negative. So they repel. You're not doing any washing of the slide. Be careful with this. You're not doing any washing. So what's going to happen is it's the glass that's going to be stained. My background is going to be stained, but not me. You see that? Now there's a purpose for this, and I'll explain it to you. This is different than this one. This is the positive stain. Positive staining, also called simple staining. Now look at this one. You're going to be doing this one too on Tuesday. You're going to put a drop of water right in the middle of the slide. I will demo it. You're going to add your inoculum in here, your bacteria, and you're going to on purpose spread it. Spread it out. And I'll show you how to do it. You're going to spread out the bacteria. You're going to let it air dry. Then you're going to pass it through the flame. And I mean pass it through the flame. I don't mean go like this and just sit there and watch them fry. Right? No, you're going to go literally, I'll show it to you. You're going to go like that. 1, 2, 3, done. So you're going to pass it through the flame, and that's called heat fixing. So what's heat fixing going to do? It's going to allow your bacteria to stick to the glass. Why? Because you're about to wash them. If you don't heat fix them, and then you wash, there's a very good chance that you will take everything off the slide and you won't see anything. So you have to heat fix it because there's a washing procedure. Watch this one. You did not have to heat fix this one because there's no washing procedure. You see the difference between the two? If you're washing it, you have to heat fix it. If you're not washing it, then you don't have to heat fix it. You do not wash this one. No heat fixing. But this one you have to heat fix because there's going to be a step where you have to wash. If you don't heat fix, that wash is going to wash literally everything off. So what does the heat fixing do again? It allows the cells to stick to the slide to be able to withstand the washing pressures. So wait a minute. When I heat the slide, even though I'm doing it really fast, the reason why they stick to the slide is because they literally dehydrate. They lose water. So these cells will dehydrate a little bit at least on the slide. These cells will not. Do you agree? So think about this. Which one will retain its normal shape? Will it be the one that's not dry or the one that is dried?
Dry.
Which one?
Not dry.
Not dry or dried?
Not dry.
Not dry.
Because
I mean, if I'm not dry, then you know, okay, this is the shape of the ore. But if it dries, it crumbles like that. It loses shape, right?
Yes.
So which one would you use if you want to calculate the cell size accurately?
This one?
This
Not
one.
dry. Yeah.
See, watch. If the cell is, let's say, this big, and you want to measure that size from here to here accurately, you use this procedure. Because you're not heat fixing. You're not shrinking them. You're not causing them to lose water. But when you do this procedure, the heat fixing, watch, causes them to do this. Watch. Go ahead, measure this. You can still measure it, but it won't be accurate. And that's the key word on a question on the exam. Which of the two procedures would you use to measure the size of a bacterial cell accurately? It's negative staining. But the reason why is because in negative staining, there's no heat fixing because there's no washing. We catching all of that? So, I mean, you can still measure their size here, knowing that you're not going to get an accurate size. Okay, then after the heat fix, you're gonna add the stain. You're gonna wash the stain off. So the background stain is gonna be washed off. But it's the cell that gets stained. So the cell will stain. Oh, hang on now. That must be a positive stain then. Yes, it is. If the negative stain repelled to the point where the cells are not stained, then why would this cell stain? Because this is a positive stain. The cell is negatively charged, and the stain is positively charged. And what does plus and minus do? They stick to each other. And the interaction is strong enough to withstand the washing pressures.
So, when the cell stains is positive and when the background stains it's negative?
Say again?
When the cell itself stains, it's positive, and when the background stains, it's negative.
No, see, the cell is negative.
The cell is negative, yeah.
This cell is negative and this cell is negative. The procedure is called negative staining, positive staining, named after the charge on the stain. Negative staining uses a negatively charged stain that will not attach to the negatively charged cell, but to the background. Got it? In positive staining, the stain is positively charged, and it will stick to the negatively charged cell, and because you're washing, the stain comes off of the background. So the background is clear, but the cell itself is stained. Pretty cool, huh? You guys are gonna be so happy on Tuesday after you do this and produce amazing images. You'll see. Yeah.
So if you're looking for accurate size and negatives, and what are you looking for in the simple staining?
Oh, you're just looking at it.
Okay.
Yeah, you're saying, oh, yeah, it's round. Oh, it's bacillus. Oh, it's a diplo. Those kind of things. Yeah. But if I ask you, I want you to measure the size of this cell, right away, negative staining.
Yeah.
If you want it accurately.
Because there's
Good.
no heat fixing.
All right, I will revisit this, of course, on Tuesday, because you're gonna actually do it on Tuesday. By what? By demoing it. I will actually show it to you, and you will do it, and you will go all the way to oil immersion with the microscope on Tuesday. So what you asked right here, what would you look for when you use positive staining? The shapes, the arrangements, and we already talked about that. And come 2 weeks from now, you're gonna do what's called differential staining. Listen to this one. Differential staining helps you identify the bacteria that you're using and categorizes it either gram positive or gram negative. If you are using the gram staining procedure, you only have one of two possible outcomes: a gram positive cell or a gram negative cell. Those are the two outcomes. But the question now is, what's different about them? I'll tell you. Actually, you're gonna tell me. I'll explain to you what I'm saying. But let's just look at the procedure. After you're done with this procedure, you're gonna say, you see the blue ones, Dr. Saad, the purple ones? Yeah, those are gram positive. How do you know? Because they're blue or purple. That color tells you, I'm talking about these guys, and these guys, this guy. That's a gram positive cell. What about the other ones, the pink ones, gram negative? The pink ones are gram negative, and the purple ones are gram positive. That's the standard procedure here. After you're done with this procedure, that's how you categorize them based on gram positive or gram negative. Now the shape is something different. So in this case, this is coccus. So you're gonna say gram positive coccus shaped bacteria. And in this case, this is rod shaped. You're gonna say gram negative rod shaped. But we're not worried about the shapes here. We're more worried about, is it gram positive or is it gram negative? Purple, gram positive. Pink, gram negative. Sounds good? But what's the actual difference between the two? the type of cell wall. The gram-positive cell wall is a little different than the gram-negative cell wall. And that's what we're taking advantage of when we do this stain. It's a staining procedure put together by Dr. Graham from a long time ago. Dr. Graham put this staining procedure together to identify or to distinguish between the gram-positive and the gram-negative bacteria. And that's why this is called differential staining. See, get it now? Distinguish, differential. Here's another one. There's something called differential media, and now there's something called differential staining. And what do you do in differential media? You're distinguishing between the fermenter and the non-fermenter. Remember that?
Mm-hmm.
What are you doing here? You're distinguishing between the gram-positive and the gram-negative. That's why I tell you, every time you hear the word differential, right away, distinguish. There you go. So look what we do with this. You're going to put both types of, by the way, this is a student-produced sample here. It's a beautiful slide. You're going to, on purpose on that day, mix both of them on the same slide. On purpose. And then you're going to add, after you heat fix, you're going to add the crystal violet to both of them. So the gram-positive and the gram-negative will be both purple in color. Oh, wait a minute. If I stop here, that's a positive stain. Yeah. So a gram staining procedure starts as a positive stain, similar to what you're going to do on Tuesday. So if you only stain it with crystal violet, and that's it, that's similar to what you're going to do next week. But that's not what you're going to do. You're going to start it like that, but then there's other steps. So they will both be purple. You won't be able to tell which one is which, because they will all be purple. Then what are you going to do? You're going to add grams iodine. Grams iodine is like a cement. And that's what mordant means. Mordant is like a cement. Look what this guy is going to do. The grams iodine is going to cement in the crystal violet in the gram-positive cell wall, but not the gram-negative cell wall. So it's going to trap the crystal violet in the gram-positive cell wall, and there's a reason behind that, and I'll tell you later. But not the gram-negative cell wall. But you won't be able to know that yet until you decolorize it. You add an alcohol. You start removing the crystal violet, but then you notice something. What? This guy retains the color, but this guy loses it. You see that? Why did this guy retain the color? Because of the mordant. The mordant trapped the crystal violet in the gram-positive cell wall, but not the gram-negative cell wall. So when you add the decolorizer, the crystal violet just comes off of the gram-negative cell wall. You lose it. You lose the color. So if you stop at this point, you'll see these under the microscope, but you won't see these. They won't have any color. But then you do what's called a counter stain. You add another stain, and it's called safranin. And safranin now will stain this one. It will stain the one that's not stained. That's why you end up with a purple gram-positive and a pink gram-negative. Beautiful procedure. Can you teach this in 1 week from now? I hope so. I will assign something for you guys before you leave here, and it requires you to go home and finish this unit, because you will be teaching the rest of it. I don't have time to tell you what the flagella does and what then you're going to tell me that. You're going to teach that to me. And I'll tell you from which slide you will be responsible for, and I'll be checking that next week. But let me finish this here. some of the stains that we use are called special stains. Not because they're special, because they stain special things, like the flagella. A specific stain is used to stain flagella, for example, like you see here, or the capsule. Some bacteria have capsules around them to protect them. So those would be referred to as special stains, or the endospore. This purple thing here, that's the endospore. This is the actual living cell that's producing these endospores. The endospore is actually initially within the cell. See, the idea of the endospore is this. This cell knows it's about to die. This thing is amazing. It knows it's about to die. The environment is not good. And what would that be in the world of bacteria? Food. Ran out of food. I'm about to die. Hey, I can produce an endospore. Not all bacteria can do this. I, however, can produce an endospore. Why? So when I die, I'll come back later. That's what it does.
The reincarnation.
Yeah, it's like a little seed. It's no different than a plant seed, right? The main cell will die, but right before it dies, it produces an endospore that is very resistant to dying. It's inactive, so it doesn't need food. So it just sits there. It just sits there, waiting for the food to come back. And once the food comes back, it will reproduce more new bacterial cells. This slide is showing you that some bacteria can position the endospore in the middle, a little bit of a detail. Some position them on the one end of the cell, and some position them somewhere in between, subterminal. Central, terminal, somewhere in between, subterminal. That's just the positioning of the endospore. And we'll talk more about endospores. The final I of the 5 I's is identification. Do you remember why we need to do identification? For proper,
For the right treatment.
see?
For the right treatment.
Treatment, proper treatment, yeah. So after you gather all the information about your unknown bacteria, you're gonna go into this Burgess manual. It is this thick. And you're gonna sift through it. Oh, coccus, gram-positive, it likes oxygen. You see that? Until you identify what are you working with. We are not doing that. We're not doing it using this. We're doing it, but not using, thank God, this. So there is one lab that you're gonna come in, and guess what? I give you a tube. And what's the name of that tube? A. There's no bacteria named A. B, C, D, E. We have 5 of them. And I give one per group. And your job is 1 week later, what? Tell me the genus and the species name of your unknown. So you're going to run all these tests and identify your unknown. But we're not going to use the Burgess manual. We'll use something that we can manage. Sounds good? That's the fun lab. Okay. Any questions?